Network Troubleshooting. About this module. Welcome to the Network Troubleshooting module. In this module, you'll discover key skills to troubleshoot a wide range of network issues that an IT support technician might encounter. These skills are essential to resolve wired and wireless network issues to keep organizations connected to their business partners. You'll explore the CompTIA troubleshooting methodology and Open Systems Interconnection (OSI) model for network troubleshooting. You'll learn about common network issues and the process IT support technicians use to isolate a network issue. You'll discover the steps for checking and resolving network hardware issues on wired networks and explore commands to perform checks on network configurations. You'll use a troubleshooting tool to capture and analyze network data for a scenario. Then, you'll focus on common troubleshooting steps for wireless networks, including checking indicator lights on routers and selecting a wireless network testing method for different scenarios. Learning objectives. After completing this module, you should be able to follow a network troubleshooting methodology, explain the process to isolate common network issues, use a troubleshooting tool to capture and analyze network data for a scenario, follow the steps to check and resolve hardware issues for a wired network, use network commands to help troubleshoot wired network issues, change a DNS server to resolve a DNS resolution issue, apply common methods to troubleshoot wireless networks, select a wireless network testing method given a scenario. About this lesson, network troubleshooting methodologies. Network issues can impact an entire organization. If users cannot access the network and internet resources they need in a timely manner, they can't perform their jobs. Therefore, identifying and locating the source of an issue is a key skill for an IT support technician. In this lesson, you'll explore two popular network troubleshooting methodologies. You'll also learn about common network issues, where they might occur, and the scope and scale of their impact. You'll also simulate using Wireshark, a troubleshooting tool that helps IT support technicians capture and analyze network data. Network troubleshooting methodologies. If you've ever had trouble accessing a web page or application while on public Wi-Fi or had a virtual work meeting disconnect while you're at home, you've likely experienced network issues. Understanding how to troubleshoot networks is not just a convenient skill to have at home for when connections fail. It's an important skill for IT support technicians in a business environment. While a dropped connection at home might interrupt a movie stream or pause a video game, in an organization, the stakes are higher. Network downtime is a period of time when the network is unresponsive to users. Network downtime can be particularly damaging for online businesses or businesses that rely on online applications. Each minute offline hinders customer interactions, restricts employee access to cloud-based resources, makes online tools unusable for employees, results in significant financial loss. So, resolving network issues swiftly and effectively is essential to minimize financial impacts and restore business operations to their full capacity. Diagnosing complex network connectivity issues requires a structured approach. Network problems can be complicated, time-sensitive, and expensive to troubleshoot and fix. IT support technicians can use network troubleshooting methodologies to efficiently troubleshoot network issues. Network troubleshooting methodologies are systematic processes that IT support technicians use to identify, diagnose, and resolve computer network problems. A structured methodology helps ensure that issues are addressed efficiently. Network troubleshooting methodologies include the CompTIA troubleshooting methodology and the Open Systems Interconnection (OSI) model. Let's explore each of these in more depth. Network troubleshooting with the CompTIA troubleshooting methodology. An IT support technician can use the CompTIA network troubleshooting methodology to systematically address and resolve complex network issues. For example, they can use it to troubleshoot packet loss that affects users in different locations, identify intermittent or recurring problems, such as irregular disconnections, ensure network reliability after new installations or security breaches. Introduction. The CompTIA troubleshooting methodology consists of 7 steps. Step 1. Identify the problem. 2 people looking at a computer with one of them holding a magnifying glass over a web page. The first step is to identify the network issue. In this step, IT support technicians should assess the network's current state using network troubleshooting tools, such as network analyzers or packet sniffers. Attempt to replicate the issue on test hardware or software to help confirm the location of the problem. Engage with network users to learn about errors or difficulties they have encountered. Review any recent system changes, such as new hardware, additional users or devices, or software updates that could have triggered the problem. Step 2. Establish a theory of probable cause. The back of a woman's head has a conversation bubble above it and the back of a man's head has a light bulb above it. Once the technician has identified the problem, the next step is to develop a working theory of the probable causes. The technician should base this theory on the information gathered during the first step. They need to consider simple explanations, such as the accidental unplugging of a cable, while also considering more complex explanations, like a security breach that might not be immediately obvious. Step 3. Test the theory to determine the cause. A man sits in front of a laptop while holding a checklist. Testing the theory is the third step. The IT support technician can use network tools to experiment. For example, if the theory is that a network switch is malfunctioning, an IT support technician can replace it with another switch to determine if that resolves the problem. Important note: if a technician tests and disproves their theory, then they return to step 2 to establish a new theory of probable cause. Step 4. Establish a plan of action to resolve the problem. A man reviews a roadmap on a laptop. Once the IT support technician confirms a theory, it's time to develop a plan of action to resolve the issue. Depending on the issue's complexity, the plan might involve straightforward steps like rebooting the network router. More complicated solutions might require ordering new parts or rolling back software across machines. Step 5. Implement the solution. A man presses a play button on a laptop. Implementing the solution is the 5th step. The IT support technician might be able to implement some network solutions independently, but others might require collaboration with other network administrators or users. Step 6. Verify system functionality. A green check mark displays on a laptop screen. After implementing a solution, this step requires the IT support technician to verify the system's functionality. They test the network carefully to confirm they have resolved the original issue and not introduced any additional problems. Step 7. Document findings, actions, and outcomes. A man is typing on a laptop in a document titled Notes. Finally, IT support technicians document the issue. This documentation is especially important if they are likely to encounter similar network issues in the future. The documentation should include detailed descriptions of the symptoms, the developed theory, the testing strategy, and the solution. Summary. By applying each of the 7 steps of the CompTIA troubleshooting methodology, IT support technicians can successfully resolve complex network issues. Network troubleshooting with the Open Systems Interconnection (OSI) model. The Open Systems Interconnection (OSI) model is a comprehensive framework to diagnose and resolve network-related problems in various business contexts. It divides the network communication process into 7 distinct layers. Each layer represents a specific aspect of data communication. Select each marker, plus, on the following diagram to learn how each layer of the OSI model works together. Start with layer 1 and work your way up to layer 7. The OSI model. Here is the information from the table converted into full paragraphs for each layer. Layer 1. Physical layer. The physical layer deals with the physical aspects of network communication, such as cables, connectors, and network interface cards. This is the only hardware layer in the OSI model. Any issues related to cable damage, loose connections, or faulty hardware fall under the physical layer. Layer 2, Data Link Layer. The data link layer concentrates on data transfer between two directly connected devices over a physical link. It handles tasks like media access control, MAC, addressing, error detection, and flow control. Troubleshooting at the data link layer includes examining issues with MAC addresses, network collisions, or misconfigured switches. Layer 3, Network Layer. The network layer focuses on logical addressing and routing of data packets across multiple networks. Internet Protocol, IP, addresses and routers play a crucial role in this layer. Troubleshooting the network layer includes diagnosing problems with IP configurations, routing tables, or network address translation, NAT, issues. Layer 4, Transport Layer. The transport layer is responsible for end-to-end communication between devices. It ensures data integrity, flow control, and error checking. Troubleshooting at the transport layer includes identifying problems with port numbers, firewall rules, or issues with Transmission Control Protocol, TCP, or User Datagram Protocol, UDP, connections. Layer 5, Session Layer. The session layer establishes, maintains, and terminates communication sessions between applications. Troubleshooting at the session layer includes tracking down issues with session establishment or interruptions in communication between applications. Layer 6, Presentation Layer. The presentation layer is responsible for data translation, encryption, and compression. It ensures that data is in a format that can be understood by the receiving application. Troubleshooting the presentation layer includes investigating problems with data formats or encryption/decryption processes. Layer 7, Application Layer. The application layer is the topmost layer of the OSI model. It's where end-user applications interact with the network. Troubleshooting at the application layer includes examining problems with specific applications, such as web browsers, email clients, or file transfer protocols. By following the OSI model and understanding the distinct responsibilities of each layer, IT support technicians can efficiently isolate and resolve issues within complex network infrastructures. This systematic approach helps ensure smooth and reliable communication across interconnected systems. Common network issues. Common network issues often directly impact the user experience. These issues range from a noticeable slowdown in network responsiveness to an inability to access necessary services, such as email or video meetings. IT support technicians group network issues into two categories: connectivity issues, performance issues. Given the broad spectrum of network issues, it is helpful for you to understand the symptoms and causes of some common network issues. Let's go over these. A man working on a laptop. Connectivity issues. Users might experience connectivity issues for a range of reasons. Network configuration errors. Settings on networking devices that don't support the intended network design prevent devices from connecting or communicating properly. Users might be unable to access the network or the Internet. They will receive limited connectivity or no Internet access warnings or encounter intermittent connectivity and sudden dropouts. Security configurations that are too restrictive can inadvertently block legitimate network traffic. Users will find that they cannot access specific websites or services. They might also receive error messages indicating that an application cannot connect to the Internet or a remote server. Wide Area Network, WAN, problems. Connectivity issues in the wide area network, WAN, can cause network interruptions or slow performance across multiple locations. Users will suffer intermittent disconnections, requiring frequent re-authentication or manual reconnection. Physical hardware malfunctions. Failed networking equipment can completely halt network traffic, causing outages or instability. Users experience a complete loss of network connectivity when essential hardware like routers or switches fail. Users notice no activity from network indicator lights, suggesting that the device is malfunctioning or not receiving power. Network Interface Card, NIC, issues can result in devices being unable to connect to the network or experiencing poor performance. Users encounter frequent network disconnections or unusually slow network speeds, potentially pointing to a failing NIC or degraded hardware performance. Wireless interference or weak signals. Interference from overlapping channels and distance from Wi-Fi access points reduces signal strength and reliability. Users might have difficulty connecting to Wi-Fi networks. Users face disruptions in online activities. They will likely encounter decreased quality of real-time communications, such as choppy audio or video. Obstacles and interference from other electronic devices can also degrade wireless signals. Users experience intermittent connectivity and might receive limited connectivity warnings due to weakened or disrupted wireless signals. Dynamic Host Configuration Protocol, DHCP, server issues. A malfunctioning DHCP server can assign duplicate or incorrect IP addresses to devices. Users encounter a limited connectivity or no internet access warnings. They might find their network connection frequently drops, requiring them to reconnect manually. They might also receive messages about IP address conflicts. A depleted range of available IP addresses prevents new devices from connecting to the network. With no available IP address, users cannot connect to the Internet or access essential online functions and services. Domain Name System, DNS, server issues. Incorrect DNS settings or server outages prevent the translation of domain names into IP addresses. Users cannot access websites using domain names, although access might still be possible using the IP address directly. Users might receive error messages such as DNS probe finished no internet or server DNS address could not be found. They might also find that web pages are slow to load due to delays in resolving domain names to IP addresses. Delays in DNS record updates or caching issues can cause outdated or slow domain name resolution. Users will struggle with web navigation issues, enduring slow website loading times and frequent timeout errors. Firewall and security software problems. Firewall configurations that are too strict can inadvertently block necessary network communications. Users might find that they cannot reach specific websites or online services. Users might receive error messages indicating an application cannot connect to the Internet or a remote server. Incorrect port forwarding settings can disrupt the external connections that certain applications need. Users' attempts to send or receive files, particularly through peer-to-peer applications or direct connections, might fail. Users will experience difficulties with VPN and remote access. They might also have issues with stable connections to work or home networks from remote locations. Virtual Private Network, VPN, and remote access misconfiguration. Improper VPN configuration can lead to failure in establishing or maintaining a secure remote connection. Users encounter intermittent connectivity, with network access being unpredictably available and then suddenly dropping. Users will experience difficulties with VPN and remote access. They might also have issues with stable connections to work or home networks from remote locations. Problems with tunneling or encryption protocols can compromise the stability and security of VPN connections. Users might repeatedly receive prompts to authenticate back into the network because the device cannot maintain a stable IP address. Users suffer from intermittent disconnections, requiring frequent re-authentication or manual reconnection efforts. Performance issues. Performance issues are likely to originate from three main causes. Internet Service Provider, ISP, problems. Problems originating from the ISP can lead to a complete loss of Internet access or reduced network performance. Users experience a noticeable decrease in Internet and network speeds, particularly during peak usage times. Users might repeatedly receive prompts to authenticate to the network because the device cannot maintain a stable IP address. Network congestion. When network traffic exceeds capacity, it results in reduced speed and reliability for all users. Users face a disruption of online activities such as streaming, VoIP calls, or video conferences. Users notice decreased quality of real-time communications, including choppy audio or video. Users experience slower data transfers, prolonged downloading and uploading times, and delays when opening or saving files over the network. A lack of sufficient network infrastructure to handle peak loads can lead to widespread performance issues. Users encounter increased latency, longer response times for clicks and commands, and noticeable delays in running network-dependent applications or databases. Users face buffering and lag in streaming media, with videos and music pausing frequently and disruptions in real-time audio or video streams. Software and server issues. When demand overloads server hardware or if it fails, users will notice an impact on the availability and performance of applications. They might notice high CPU or memory usage on network monitoring tools and increased response times from servers, impacting all server-based applications. There is likely to be a spike in help desk tickets related to slow network performance, expressing increased frustration with network-dependent activities. Software malfunctions on servers can also disrupt essential network functions and services. Users find internal network services like printing or file sharing unresponsive or slow. Significant delays in authentication processes, such as logging into domains, are likely. Users might also face difficulties and delays when accessing shared resources, such as network drives and documents. Because there are so many symptoms and causes of network issues, let's look at the steps an IT support technician can take to identify the location of the problem. Steps to isolate a network issue. Because user-reported symptoms can point to multiple potential network issues, it can be challenging for IT support technicians to immediately identify the underlying problem. There are simple steps that an IT support technician can take to isolate the network problem and identify the segments or components where the issue originates. Margot is an IT support technician who documented the process that her team will consistently follow on projects to isolate network problems at her company. Let's follow her process. A woman wearing glasses typing on a laptop. Step 1. Review a network diagram. Start by reviewing a network diagram to visualize and understand the components in the network and the connections between them. If a diagram is not available, create a new, up-to-date diagram at the start of the problem isolation process. A network diagram showing 4 routers connected together, each with multiple desktop and laptop computers connecting to them. Step 2. Segment the network or isolate components. There are 2 ways to divide the network into manageable sections. Split the network logically or physically into smaller segments to test them independently. Use virtual local area networks, VLANs, or subnets to divide them logically. Disconnect parts of the network to divide them physically. Isolate components such as cables, switches, routers, or servers to test their functionality. A diagram of 2 network sections with a red cross on the connection between them showing segmentation. Step 3. Test and compare to baseline data. Once the network is divided, perform tests on the sections to identify the origin of the issue. Tests can include the following. Compare current network performance data against established baselines to identify anomalies. Perform targeted tests on specific network components, such as ping, traceroutes, and network monitoring tool tests. Test from both the client and server sides to pinpoint the location of the issue within the network stack. Set up controlled test environments to replicate and diagnose issues. A computer monitor showing graphs and test results, including a pie chart, bar graph, and stopwatch. Step 4. Eliminate functioning segments or components. Finally, narrow down the location of the network issue by a process of elimination. Rule out components or segments that are functioning correctly to eventually find the problematic segment or component. A diagram of 2 network sections with the network on the left in gray showing it has been eliminated. Isolating problems using these steps enables technicians like those on Margot's team to then carefully analyze network issues, ensuring accurate diagnosis and efficient resolution. You've learned about common network issues and how to isolate them. Next, let's explore ways to categorize issues. Client-side issues versus server-side issues. When isolating network issues, IT support technicians must identify whether an issue is client-side or server-side. Client-side issues happen on end-user devices, such as desktops, laptops, or mobile devices. Server-side issues happen on the servers that provide network resources and services to those client devices. To determine the origin of the problem, IT support technicians conduct tests on both the client and the server. Client-side test. Specific diagnostic steps for client-side issues might include testing connectivity using tools like ping or traceroute, verifying physical connectivity, such as cables and routers, checking network configuration settings like IP address, subnet mask, gateway, and DNS server, ensuring the correct operation of network drivers and hardware. Server-side test. Specific diagnostic steps for server-side issues might include monitoring server resource utilization to check for overloads, reviewing server logs for errors that correspond to user-reported issues, validating that network services are running and configured correctly. By running tests on both the client and server, IT support technicians can locate the source of a problem more rapidly, leading to quicker resolutions and minimized downtime. Activity: use Wireshark to capture and analyze network data. Employability skills: attention to detail, learning agility, collaboration and teaming. In this activity, you'll explore a troubleshooting tool to capture and analyze network data for a scenario. Wireshark opens in a new tab, is an open-source network protocol analyzer. It is used across industries for network troubleshooting and analysis. It allows IT support technicians and network administrators to capture live network data in a readable and searchable format. This capture enables technicians and administrators to inspect and analyze network data more easily. Wireshark supports many protocols and media types, making it useful for several network monitoring tasks. Across industries for network troubleshooting and analysis. It allows IT support technicians and network administrators to capture live network data in a readable and searchable format. This capture enables technicians and administrators to inspect and analyze network data more easily. Wireshark supports many protocols and media types, making it useful for several network monitoring tasks. IT support technicians can use Wireshark during troubleshooting, such as for network analysis, while identifying or isolating network problems or testing a theory of probable cause. Scenario: you are working on a new project with Danny, a senior IT support technician. You're new to using Wireshark, so he's going to walk you through how to use it to capture and analyze network data. Your task is to capture packets from the Wi-Fi network because employees have been reporting issues accessing specific websites while connected to the company's Wi-Fi network. Man using laptop and headphones. Important note: you do not need to download or use Wireshark to complete the steps in this simulation. Simply follow the simulation steps in this fictitious scenario. In this simulation, you will follow Danny's directions to capture and analyze network data using Wireshark. You will get to explore the Wireshark interface, capture data, analyze the packets and their details, and then review statistics. There are 31 steps to complete. Task 1: Prepare for capture. Step 1/31. When you open Wireshark, the Welcome to Wireshark page displays a list of available network interfaces on your system. Danny tells you that you'll be analyzing data on your company's Wi-Fi and 0 network interface. Notice there is a spark line alongside to this network interface name. This spark line means that the interface is currently active. Select the Wi-Fi and 0 network interface. Step 2/31. Danny asks you to check the capture options before starting the capture process. Select Capture on the menu bar. Step 3/31. On the capture menu, select Options. Step 4/31. Select the green bookmark next to the capture filter for selected interfaces drop-down list and take a moment to review the filter options available. Step 5/31. Danny reminds you that you want to capture all the traffic on the company's network interface, so you don't select any of the filter options. This ensures that you can view all the captured data. Select the next arrow to continue. Task 2, Capture and filter data. Step 6/31. Danny tells you that you are now ready to start the capture. Select Start. Step 7/31. After collecting data for 10 minutes, Danny tells you to stop the capture. Select Capture on the menu bar. Step 8/31. On the capture menu, select Stop. Step 9/31. Danny compliments you on your work. Now, you have a lot of network data to analyze. Select the next arrow to continue. Step 10/31. Danny explains that Wireshark is displaying all of the data packets you captured in the upper pane. Notice that in the protocol column, there are TCP, UDP, and TLS events listed. TCP packets are calls to websites, UDP packets are DNS lookups, and TLS packets are security communications. Select the next arrow to continue. Step 11/31. Danny points out that the Packet Details pane shows the details for a selected packet. Select the next arrow to continue. Step 12/31. Danny shares that the Packet Bytes pane shows the raw data in hexadecimal format. Select the next arrow to continue. Step 13/31. Because you are investigating website access issues, Danny suggests filtering the capture results to show only the HTTP packets. This will help you to determine if website requests are successfully reaching their destinations and if the responses are appropriate. Select the next arrow to continue. Step 14/31. In the Apply a Display Filter field, type HTTP. Then, press Enter to continue. Step 15/31. Here are your filtered results. Next, Danny asks you to review the packets. Select the next arrow to continue. Task 3, Inspect Packet Details. Step 16/31. As you scroll through the list of captured data packets, Danny points out that line 44 displays as red text on a black background. This formatting usually indicates TCP packets with problems, such as retransmissions, which could suggest packet loss or network congestion. Double-click line 44 to expand the details of the packet. Step 17/31. This shows the details of the protocol layers, such as Ethernet, IP, TCP, and the associated payload data. Notice the transmission control protocol line. Select the gray arrow at the start of the line to display more information. Step 18/31. Now you can view more information. Notice that the last line shows this packet is a retransmission. Danny tells you that a common cause of retransmissions is packet loss due to network congestion, faulty hardware, or signal degradation. This is useful information for your troubleshooting. Well done! Select the next arrow to continue. Task 4, Save and Capture. Step 19/31. Danny says that now you've found some potential issues you need to examine further. But first, you should save the data capture. Select File on the menu bar. Step 20/31. On the File menu, select Save. Step 21/31. In the File Name field, type Connectivity Capture. Then, press Enter. Step 22/31. Notice that Wireshark saves the capture file as a.pgap by default. Select Save to save the data so you can analyze it further. Task 5, Use Statistics and Analysis Tools. Step 23/31. Because the packet retransmission that you found suggests network congestion, faulty hardware, or signal degradation, Danny suggests looking into the endpoint statistics from the data capture. He explains that this can help identify if a specific company device is frequently involved in connectivity issues or if there's an unusual amount of traffic from a particular endpoint, which could be a sign of network misuse or a malfunctioning device. Select the next arrow to continue. Step 24/31. Select Statistics on the menu bar. Step 25/31. On the Statistics menu, select Endpoints. Step 26/31. Review the data in the Packets column. Notice that the last two lines have more than 40,000 packets, which is significantly higher than the other lines. A high number of packets can be normal for a server or a busy client but should always be checked. Danny suggests you investigate the address further to ensure this traffic is legitimate and expected. Select the next arrow to continue. Step 27/31. Danny asks you to close the Endpoints window. Select Close. Step 28/31. From your discovery of retransmissions and the endpoints with a significant number of packets, Danny suggests you look at the conversation statistics. Select Statistics on the menu bar. Step 29/31. On the Statistics menu, select Conversations. Step 30/31. To identify the conversation with the high packet count, review the last row, which has a value of 42,935 in the Packets column. Notice that the conversation is between endpoints F8:4D89:8 F4 F19 and 98 F2B3 F5 F9D. These are the two endpoints you identified earlier. Danny asks you to write down the two endpoint addresses for further investigation. Select the next arrow to continue. Step 31/31. Danny asks you to close the Conversations window. Select Close. Well done! You and Danny gathered valuable information using Wireshark to capture network data to troubleshoot the Wi-Fi access issue. Using Wireshark, you and Danny observed a notable network exchange, 10 MB sent and 4 MB received in about 7 minutes. To determine if this is normal, Danny will investigate the typical behavior of these endpoints. He'll also assess if the endpoint roles, like a server and workstation, justify such traffic. For example, a design workstation might need to download large files, but an ordinary office workstation doing so might be problematic. Danny plans to conduct longer network captures during peak times to identify if such traffic patterns cause network congestion and intermittent connectivity issues. By relating the timing of the data transfers with the connectivity issues and considering the roles of the endpoints, you and Danny can develop a strategy to mitigate the issues. This could involve adjusting network configurations, prioritizing traffic, and scheduling large transfers for off-peak times. Classifying issues by scope and scale. IT support technicians face complex challenges when troubleshooting network issues. Understanding the scope and scale of a network problem is a key skill in effective troubleshooting. A man working on a computer in an office. Scope refers to the range or extent of a network problem. It identifies which parts of the network the issue is affecting. Technicians categorize scope as either localized or widespread. Localized scope: the issue affects a single part of the network, such as one workstation, one switch, or a segment of the network. IT support technicians can often isolate the issue to a specific hardware device, user, or application. Widespread scope: the issue affects a large portion of the network or even the entire network, indicating a more systemic problem. This issue might involve multiple network devices, such as routers or servers, and impact many users and services. A magnifying glass with a check mark in the center of the lens. Localized versus widespread issues. Identifying whether a network problem is localized to a single user or device, affecting a larger segment of the network, or even impacting the entire network is essential. IT support technicians can determine the scope of the network issue with techniques such as user reports, network monitoring tools, and comparative analysis of network traffic patterns. For example, if only one user cannot access the network, the problem is likely localized. However, the issue might be widespread if reports arise from different network segments. Scale refers to the magnitude of the network issue in terms of its impact on business operations and processes. Technicians assess how critical the affected network services are to the organization's functionality. Small-scale impact: the issue has a minor impact on business operations, perhaps affecting non-critical systems or causing inconveniences that hinder the productivity of a very limited group of individuals. Large-scale impact, the issue has a significant or critical impact. It might halt essential services, cause major disruptions to business operations, lead to considerable productivity and financial losses. A set of weighing scales. Small-scale versus large-scale issues. Assessing the impact of a network issue on users and business processes is important for understanding the severity of the problem. A small-scale issue might interrupt the productivity of a single employee. In contrast, a large-scale issue might halt an entire organization's operations. To assess the impact of a network issue, IT support technicians must evaluate the affected services, the number of users impacted, and how critical the disrupted services are to daily business functions. Summary and looking ahead. In this lesson, you learned how to use two network troubleshooting methodologies, the CompTIA troubleshooting methodology and the OSI model. You explored common network issues and the steps to isolate them to identify the cause of the problem. You also practiced using Wireshark as a network troubleshooting tool to capture network data for a scenario. Performing these tasks in a timely manner is essential to keep organizations connected and enable users to complete their daily tasks. The next lesson covers the process of troubleshooting wired networks. You will learn how to identify and resolve common problems that occur in wired networks. About this lesson, troubleshoot a wired network. In this lesson, you'll focus on the steps to troubleshoot common issues that occur in a wired network. You'll discover how to identify and resolve hardware issues and how to use network utilities to check for configuration and connectivity issues. You'll also learn to troubleshoot domain name system, DNS, resolution problems and change to a functioning DNS server. Finally, you'll investigate the issues that antivirus and anti-malware software can cause on a wired network. Determine and resolve hardware issues. In the Open Systems Interconnection, OSI, model, the physical layer handles hardware connections, such as cables and switches. They send and receive the network's basic signals. Consider a house's plumbing. If the plumber doesn't connect the pipes properly or if the pipes leak, water won't reach the taps. Likewise, problems with the network's pipes disrupt data flow, affecting services like the internet or email. Unplugged cables, failed hardware, or incorrectly set up new installations often cause network issues at this physical level. Determining hardware issues. Introduction. When an issue arises in a wired network, checking the physical layer is a great place to start. It enables an IT support technician to eliminate or confirm basic problems such as disconnected cables, faulty hardware, or visible damage. This process is quick compared to diagnosing issues at higher layers, which can be more time-consuming. Let's follow the 6 steps IT support technicians use to determine the cause of a wired network issue. Step 1. Gather information about the issue. During this step, IT support technicians gather detailed information from users experiencing network issues. They focus on the symptoms users are experiencing and any recent changes or incidents that might be related to the problem. In particular, IT support technicians should check for the following: new equipment installations, recent power outages, changes in network configuration. Additionally, technicians might review documentation to familiarize themselves with specific hardware details and configurations, the network's architecture, each device's current settings, and the history of any previous issues. These can all provide valuable context for the current problem. Step 2. Conduct a visual inspection. Next, IT support technicians ensure that all devices are actively receiving electricity and conduct a visual inspection. They check for obvious signs of damage to cables, devices, and connectors. This step is crucial, as it helps identify issues like severed cables or burnt-out components. Additionally, they check the status indicator lights on all network hardware. These lights can provide diagnostics through various color codes and blinking patterns that indicate the status of power, connectivity, and data transmission. This kind of thorough visual inspection can quickly pinpoint the source of many common network problems. Step 3. Physically check cables and power. In this step, IT support technicians ensure all cables are connected and properly seated. Firmly seating a cable means it is fully inserted and locked in place, providing a secure connection that guarantees reliable communication and power flow. IT support technicians can use cable testers to measure the length and check the integrity of the cables, confirming there are no breaks or quality issues that could impair network function. Additionally, they might use a multimeter to test for power issues. This test helps technicians ensure that the correct voltage is reaching the network devices and that no electrical faults might cause service disruptions. Step 4. Isolate and substitute faulty hardware. During this step, IT support technicians isolate the physical issue by swapping out cables or devices they suspect to be faulty with ones they confirm to be in working order. This substitution helps technicians determine whether or not the issue is with the specific piece of hardware. Technicians also check for overheating components, a common sign of hardware failure. Step 5. Conduct an environmental check. When conducting an environmental check, IT support technicians check that extreme temperatures or moisture are not impacting devices. They also check for potential sources of electromagnetic interference from nearby machinery or power lines that can disrupt network signals. Technicians also confirm that cable length does not exceed specified limits and that cables are not bent beyond their minimum bend radius. For fiber optic cables, the minimum bend radius is usually about 10 times the outer diameter of the cable. For example, if a fiber optic cable has an outer diameter of 2 mm, its minimum bend radius would be 20 mm. For copper cables, the general rule of thumb is that the bend radius should not be less than 4 times the outer diameter of the cable. So, if the cable has an outer diameter of 6 mm, the minimum bend radius would be 24 mm. Step 6. Document findings. Finally, IT support technicians document any findings or actions taken during these steps. If they make any changes, they update network diagrams or existing documentation with those changes. Summary. After technicians have checked network hardware and identified any issues with a wired network, they resolve them. Resolving hardware issues. Once an IT support technician pinpoints the root cause of a wired network issue during a hardware inspection, there are several strategies they can employ to resolve these hardware-related problems. Select each card to reveal the ways technicians resolve the following hardware issues. Unconnected cables. Reconnect cables. Ensure all connections are secure and plug cables in firmly. Damaged components. Replace components. Swap out damaged cables or failed hardware with new, functioning replacements. Unpowered devices. Power cycle devices. Turn equipment off and on again to resolve temporary glitches. Misconfigured hardware. Reconfigure hardware. Make changes to the configuration of devices according to the network's requirements. Hot, cold, or damp conditions. Change placement. Adjust the hardware placement or improve the physical conditions to mitigate environmental impacts. Out-of-date firmware. Update firmware. Update the device software to resolve known issues and improve performance. If an IT support technician doesn't find any hardware issues or resolving such an issue doesn't solve the original problem, they need to continue investigating other areas of the network. Check configuration and connectivity using commands. The next step in troubleshooting a wired network is to check the network configuration and connectivity. IT support technicians can use network utilities in a command line interface to diagnose problems further. Review the following table to get an overview of some of these tools. View and manage IP configuration. Windows, the IP protocol configuration command displays all current TCP/IP network configuration values and refreshes DHCP and DNS settings. Linux and Mac OS. The traditional ifconfig command configures or displays the network interface configuration, though it is being phased out in favor of the IP command on Linux platforms. The IP command is a more modern replacement for ifconfig on Linux platforms that offers more features and better control. The network setup command serves as an alternative tool available only on Mac OS. Test the reachability of a host on an IP network. Windows, the ping command sends Internet Control Message Protocol, ICMP, echo request messages to the target host and listens for echo response replies to diagnose the health and reachability of a networked device. Linux and Mac OS, the ping command functions the same as it does in Windows, sending ICMP packets to network hosts. Trace the path packets take to a network host. Windows, the troubleshoot command traces the route taken by packets across an IP network. Linux and Mac OS, the traceroute command maps the journey that a packet takes from the computer to an external internet address. These tools help technicians check network connections and the flow of data from one point to another. Let's explore the commands in more detail. IP Protocol Configuration Command. IT support technicians use the IP Protocol Configuration command to verify the IP address configuration of a computer. Correct configuration is crucial for network communication. When running IP Protocol Configuration commands, technicians can check for issues such as incorrect IP addresses, subnet masks, and default gateway settings. IP protocol configuration is useful for checking that a computer has the correct configuration to receive an IP address dynamically or verifying a static IP setup. A computer monitor displaying an IP protocol configuration command. To use IP protocol configuration to troubleshoot a network, open a command prompt, type IP protocol configuration, and press Enter. The following screen capture shows the results of this command run in Windows PowerShell. The results display basic information about the network adapter on the device. If the device has multiple network adapters, the IP protocol configuration command will show results for each one. The results include each network adapter's IP address, subnet mask, and default gateway. The IP address displayed next to the IPv4 address field is the address assigned to the computer. If this address starts with 169.254, it's an address assigned by Automatic Private IP Addressing, APIPA. Windows automatically assigns this address when it can't obtain an IP address from a DHCP server, which is often the router. It's a sign that the computer is not properly communicating with the router to get a valid IP address. Try it. Open a command prompt, type IP protocol configuration, and press Enter. Take a moment to check out the results you receive. IP release and renew. Releasing and renewing an IP address is a troubleshooting method to resolve network connectivity issues, such as IP conflicts or expired IP leases. IP conflicts occur when two devices on the same network have the same IP address. Expired IP leases occur when a DHCP server assigns an IP address for a time period, and that period comes to an end. Releasing and renewing an IP address ensures that the device receives a unique and valid IP address. The release command drops the current IP address. The renew command requests a new IP address from the DHCP server, usually the router. To release an IP address, type IP protocol configuration/release and press Enter. To renew an IP address, type IP protocol configuration/renew and press Enter. Important: running the IP protocol configuration/release command will disconnect the computer from the network and the Internet. Do not try this command if loss of network connectivity will impact any work being performed on the computer. Performing an IP release and renew is often one of the first steps in network troubleshooting because it's a simple action that can resolve common issues without affecting other network configurations or devices. When troubleshooting a network, if releasing and renewing the IP address doesn't work, an IT support technician should bypass the router by connecting the computer directly to the modem with an Ethernet cable. If this action resolves the issue, the problem is likely with the router or the connection between the router and the modem. Ping command. If the issue is not with the router, it's likely to be an issue in the connection from the router to the internet. In this situation, the ping command becomes useful. IT support technicians use ping to test the connectivity between the computer and another networked device. The ping command sends 4 Internet Control Message Protocol (ICMP) echo request messages to the other device and listens for echo response replies. Ping helps to determine if the host is reachable and how long it takes to exchange packets. Lost packets or slow response times can indicate network congestion, a misconfigured router, or issues with the target host. A ping command test results showing the time taken for the ping command to complete successfully, the download speed, and the upload speed. Pinging a major, dependable server such as the Cloudflare DNS server on IP address 1.1.1.1 can test the router's reachability to the Internet. The following screen capture shows a ping command in Windows PowerShell that pings the IP address 1.1.1.1. Notice there are 4 reply lines as well as ping statistics that give the output of the ping command. The statistics show that 4 packets were sent, 4 received, and 0 packets were lost. The statistics also include information on the round-trip times in milliseconds, with a minimum of 15 milliseconds, a maximum of 27 milliseconds, and an average of 21 milliseconds. Try it. Open a command prompt, type ping 1.1.1.1, and press enter. Take a moment to check out the results you receive. Sometimes, while troubleshooting issues, IT support technicians need the ping command to run continuously while they are diagnosing the problem. To have the ping run continuously, add the T switch to the end of the ping command. Should the pings not go through, the command prompt will show basic diagnostic information to help identify the connectivity issue. Try it. Open a command prompt, type ping 1.1.1.1t, and press enter. To stop the continuous ping command, press Ctrl+C. Executing a ping command can provide an IT support technician with information on network connectivity and performance. It verifies that a device can communicate with another device on the network or the Internet. IT support technicians can use ping to determine if data packets are being lost during transmission, which indicates problems such as network congestion, signal disruptions, or hardware failures. Traceroute command. When the ping command suggests the router is functioning, but there's no connectivity beyond it, IT support technicians often turn to the traceroute command for a deeper analysis. This command maps the journey a packet of data takes from the computer to the target destination, revealing each hop along the path. It sends data packets with incrementally increasing time to live, TTL, values. Each hop along the path decreases the TTL of a packet by 1. When the TTL reaches 0, the packet is discarded, and the hop sends back an ICMP time exceeded message. Traceroute records the source of each of these messages, providing the technician with a list of each router it passes through on the way to the destination. A traceroute command prompt screen that states, enter the network address to trace an internet route to and then the URL example.com is in the field. The results show the traceroute has started. This process helps technicians pinpoint where data packets are getting delayed or lost. It can identify problematic nodes in the network. A node is any device in the network, such as a server, router, switch, or end-user device like a computer. These nodes can cause slow response times or complete connection failures. If the traceroute completes successfully but with delays, the network might have congestion or inefficient routing. If the traceroute fails to complete, the connection might have a break in it. Reasons for a break include network outages, misconfigurations, or firewalls blocking the traceroute packets. To perform a traceroute to the Cloudflare DNS server, open the command prompt and type traceroute 1.1.1.1 on Mac OS or Linux systems or type traceroute 1.1.1.1 on a Windows system. As the command executes, the output shows each hop and the time it took to reach it. This visual path can be invaluable when diagnosing where the issue lies within the network. The following screen capture shows the traceroute command in Windows PowerShell to trace the route to the IP address 1.1.1.1. Each numbered line shows a hop along the route from the source to the destination IP address. In lines 2, 4, 5, and 6, there are asterisks, instead of times, indicating that those hops did not respond to the request within the timeout period. Try it. Open a command prompt or terminal. On a Windows device, type troubleshoot 1.1.1.1 and press Enter. On a Mac OS or Linux device, type traceroute 1.1.1.1 and press Enter. Watch as the data hops from router to router, revealing the path to the destination. Running a traceroute gives an IT support technician a detailed view of the network's structure and performance. Traceroute is instrumental in identifying routing issues and network bottlenecks by showing the route and measuring transit delays of packets across the network. It's a critical tool for network troubleshooting diagnosis, complementing the simplicity of ping with a more comprehensive network path analysis. Using these command tools, a technician can effectively check network configuration and connectivity issues that might not be immediately apparent through a physical hardware inspection. If ping and traceroute tests to an IP address are successful, the network connection is most likely fine. However, if websites are still inaccessible, DNS resolution might be failing. Check DNS resolution. DNS servers translate human-friendly domain names into IP addresses that computers use. If there's an issue with DNS, users might not be able to reach websites or network resources even though their internet connection is working. IT support technicians often use nslookup on a Windows system or dig on a Mac OS and Linux system to troubleshoot potential DNS resolution problems. These commands request DNS servers to resolve domain names into IP addresses. Using nslookup or dig, technicians determine whether a computer can successfully translate a website's name into an address it can connect to, which is a crucial step in accessing internet resources. The nslookup command sends a query to the DNS server specified in network settings, or a different one if specified, and returns the server's response, providing the IP address associated with the domain name. This test checks whether the DNS servers are operational and correctly resolving names. When nslookup returns an error or cannot resolve the domain name, it suggests a DNS-related problem, such as misconfigured DNS settings or issues with the DNS server itself. The dig command provides an in-depth lookup report that includes the resolved IP address and additional data that technicians can use to diagnose complex DNS issues. This data can include the query time, TTL, and any potential errors encountered during the resolution process. When using dig, appending and trace to the command reveals the path taken to resolve the domain. The following screen capture shows the results of the nslookup command in Windows PowerShell. It shows that the server that responded to the lookup is cache1.service.virginmedia.net with the address 194.168.4.100. The results also show a non-authoritative answer, which means the information in the output of the request is not coming from the domain's authoritative server but rather from a local DNS cache. Try it. To check the DNS resolution for the IBM website, open a command prompt or terminal. On a Windows device, type nslookup.ibm.com and press Enter. On a Mac OS or Linux device, type dig.ibm.com and press Enter. Running nslookup and dig commands gives IT support technicians detailed insights into DNS functionality, ensuring domain names properly resolve to IP addresses. Resolving DNS resolution issues. If an IT support technician determines there might be an issue with the DNS server, they can change to a different, reliable DNS server. Public DNS servers such as Google, 8.8.8.8 and 8.8.4.4, or Cloudflare, 1.1.1.1, are popular because they are fast and reliable and offer additional privacy and security features. Changing DNS servers can resolve common DNS resolution issues. The steps to do this vary according to the operating system on a device. Let's try the typical steps in an activity. Activity: change a DNS server on Windows. Employability skills. Problem solving, attention to detail, learning agility. In this activity, you'll perform the steps to change a DNS server. Scenario: while troubleshooting an employee's issue at your company, you determine there is an issue with the corporate DNS server that they are currently using. Your line manager asks you to update the network adapter settings on the employee's computer to temporarily use public DNS servers until the issue is fixed. In this simulation, you will use the control panel on a Windows computer to change the DNS server that the computer uses. There are 14 steps to complete. Step 1 14th. You use remote access software to access the employee's control panel on their Windows system. Select Network and Internet. Step 2 14th. Next, select Network and Sharing Center. Here is the text extracted from the image. Step 3/14. Here, you can view the employee's basic network information and set up connections, including the name of their active network. Under Control Panel Home, select Change Adapter Settings. Step 4 14th. Notice this window shows all the network connections available on the employee's computer. They are using Wi-Fi to connect to the company's network, so this is the connection that you need to change the DNS server configuration. Select Wi-Fi. Here is the text extracted from the image. Step 5/14. Then, on the toolbar, select View Status of this connection. Step 6 14th. The Wi-Fi status dialog opens. Select Properties. Step 7 14th. The Wi-Fi Properties dialog opens. You need to view the properties of the IPv4. Select Internet Protocol version 4, TCP/IPv4, in the list of items, and then select Properties. Step 8 14th. The Internet Protocol version 4, TCP/IPv4, Properties dialog opens. Notice that the preferred and alternative DNS servers are currently specified as 203.0.113.x. These are the company DNS servers that you suspect are not working properly. Your line manager wants the employee to temporarily use public DNS servers. 1.1.1.1 is a reliable Cloudflare public DNS server. In the preferred DNS server field, type 1.1.1.1 and then press Enter. Here is the text extracted from the image. Step 9/14. 8.8.8.8 is a reliable Google public DNS server. In the alternative DNS server field, type 8.8.8.8 and then press Enter. Then, select OK to save your changes. Step 10 14th. In the Wi-Fi Properties dialog, select Close. Step 11 14th. Good work! You've changed the DNS servers the employee's computer will use. Next, you should test the new configuration. Select the next arrow to continue. Step 12 14th. You can use Windows PowerShell to run the nslookup command to verify that DNS is working on the employee's computer. Select the next arrow to continue. Step 13 14th. At the C prompt, type nslookup.ibm.com, and then press Enter. Step 14 14th. The command returns the IP address for ibm.com, which shows that the DNS server configuration is successful. Select the next arrow to continue. You successfully changed the employee's computer to use a reliable, public DNS server until the issue with the corporate DNS server is resolved. You checked that this change solved the employee's connection problems by using nslookup against ibm.com. Well done! Now you know how to change a DNS server on Windows computer to secure, reliable, and publicly available DNS servers when troubleshooting a network issue. Download the Steps to Change a DNS Server document to keep as a reference for the steps to follow to change a DNS server on Windows, Mac OS, and Linux. Here is the text extracted from the image. Change a DNS server. When a computer can access the network, but websites are inaccessible, there might be an issue with the DNS server that it is using. IT support technicians often test if there is a problem with a DNS server by changing the client computer to use a public DNS server. If it can access websites when connecting to a public DNS server, then the issue is most likely with the original DNS server. The steps to change a DNS server vary depending on the operating system the client computer is running. Change a DNS server on Windows. Open the Control Panel. Select Network and Internet, select Network and Sharing Center, and select Change Adapter Settings. Select the appropriate network connection and then select Change Settings of this connection. Select Internet Protocol version 4, TCP/IPv4, and select Properties. In the bottom panel, select Use the following DNS server addresses. Type the IP address of the new DNS server and select OK. Change a DNS server on Mac OS. Select the Apple icon in the top left corner of your desktop and select System Settings. Select Network from the System Settings options. Select the current Internet connection from the list on the Network window. If using Wi-Fi, select Wi-Fi. Select Details next to the current Wi-Fi that's in use. In the menu, go to the DNS tab. Below the DNS Servers section, select the AND button to add new DNS server addresses. Type the IP address of the new DNS server. Select OK to close the Wi-Fi settings. Change a DNS server on Linux. Open a terminal from the system's application launcher. Type in the command to edit the resolve.conf file, such as sudo vim/etc/resolve.conf. Note, the vim command invokes 6 improved, vim, an advanced text editor built for command line interfaces. The sudo command gains administrative privileges, and it will prompt for a password. Once the file is open, add a new name server line by typing nameserver 8.8.8.8. This line sets the Google DNS server as the primary DNS server. Add a secondary DNS server on a new line by typing nameserver 8.8.4.4. If using Vim, save changes by typing WQ and then pressing Enter. Note, WQ stands for Write and Quit. Changing DNS servers is a common step when troubleshooting networks because DNS issues can lead to a variety of problems, including website access errors and slow internet response times. Check antivirus and anti-malware software settings. To resolve network issues, IT support technicians initially run IP settings and connectivity checks using IP protocol configuration, ping, and traceroute. If these steps don't resolve the issue, IT support technicians must check less obvious potential causes like security software. Network issues can also stem from antivirus or anti-malware software. IT support technicians should check the configuration of the security software and whether it is up to date. Let's learn about the approach by following Denzel, an IT support technician. Introduction. Meet Denzel. One morning, he receives a ticket regarding network connectivity issues that have been reported by several employees in a corporate office. His initial investigation involves basic hardware and software checks, such as IP settings and connectivity tests using IP protocol configuration, ping, and traceroute. These checks don't identify the cause of the issues, so Denzel continues troubleshooting. Denzel knows that antivirus and anti-malware software can cause network issues, so he decides to examine the security software settings. A smiling man sitting on a desk. One check for updates. Denzel starts by checking the antivirus and anti-malware software for updates. He reviews the security software logs and ensures that the latest updates are installed. He checks the security software to see if any updates are available because he knows that outdated definitions or program versions can lead to false positives or miss actual threats. He concludes the security software is up to date. 2. Review configuration settings. Denzel reviews the configuration settings of the security software. He knows that incorrect settings can cause the system to flag legitimate network activity as malicious, so he ensures that security levels are appropriately set and that there are exclusions for trusted applications and data traffic. 3. Inspect logs and quarantine. When analyzing the security software logs and quarantine areas, Denzel looks for any indications that the system might have mistakenly identified legitimate network traffic as a potential threat. This step helps him identify any false positives quickly. 4. Mitigate false positives. Denzel addresses all identified false positives by submitting relevant files or traffic patterns to the security software vendor for analysis in allow listing. He knows that allow listing is a proactive defense technique that allows only pre-approved software, applications, processes, or IP addresses to operate or communicate with the system. 5. Test security software. With caution, Denzel temporarily disables the security software to determine if doing so resolves the network issue. During this testing phase, he closely monitors the network to ensure it is not left vulnerable to actual threats. The problem stops, indicating to Denzel that the security software might be the cause. This will require reconfiguration or replacement. By following the steps to check security software, Denzel identifies and troubleshoots issues arising from the antivirus or anti-malware software. There are many types of antivirus and anti-malware software available. To check security software, IT support technicians might have to consult manuals and help resources provided by the specific software vendor to understand the steps involved. What do you think? Employability skills. Analytical thinking. In what ways did Denzel's methodical approach to checking antivirus and anti-malware software help him effectively troubleshoot the network connectivity issues? Evaluate your thinking. Does your answer account for the following? Checking antivirus and anti-malware software helped Denzel troubleshoot issues within the company network by ensuring software security through regular updates, configuring security settings to prevent misconfigurations, identifying and addressing false positives to prevent disruptions, and testing to determine if the security software was the root cause of network issues. By following these steps, he was able to identify and resolve issues while maintaining a secure and reliable network environment. Summary and looking ahead. In this lesson, you learned about troubleshooting wired networks. You learned about the tools and techniques IT support technicians use to identify and resolve common wired network issues to ensure that the networks remain functional to minimize any downtime. The next lesson covers troubleshooting wireless networks. You'll discover methods to track down the causes of problems and how best to resolve them. About this lesson, troubleshoot a wireless network. Have you ever noticed an X symbol over the Wi-Fi icon in your taskbar? Or have you had an experience when a laptop or mobile device alerts you that wireless networks aren't available, even though you're certain they are? Encountering issues with wireless connections can be frustrating, particularly if they arise during critical moments, such as when you're about to send an email. In this lesson, you'll learn about common techniques IT support technicians use to troubleshoot network issues. You'll also learn about the meaning of different wireless router lights and how technicians use the lights to troubleshoot networks. You'll explore different ways to check a network configuration and learn how technicians test wireless networks to identify and resolve network issues. Wireless network troubleshooting basics. Devi works as an IT support technician for a large corporation. She often helps troubleshoot personal network device issues for her company's employees who work from home. When employees contact her for help with slow connection speeds or unresponsive programs, she knows which questions to ask to solve problems quickly. A woman wearing a headset looking at a computer monitor. Typically, her first question is, "Have you restarted your network devices recently?" If they haven't, she walks them through the steps to restart the devices. When the employee's devices finally connect or start running at their original efficiency, they tell Devi she's a hero for solving their network problems. But, she knows that many wireless connectivity problems stem from simple hardware issues or signal interference, often the easiest and quickest issues to resolve. Let's explore some common troubleshooting methods technicians perform and why these steps often work. Power cycle network devices. Power cycling or rebooting the modem, router, or internet gateway is a standard wireless network troubleshooting method. It's typically the first action due to its simplicity and effectiveness. Power cycling works as a troubleshooting method for the following reasons. A modem with a plug near an electrical outlet and a stopwatch. Clears memory, it clears the device's random access memory, RAM. RAM can become cluttered with stale data over time, potentially leading to decreased performance or errors. Resets state, it returns the device to its initial state. If the device is in an unresponsive or unstable state, power cycling can reset temporary configurations and flush the current states of the software. Interrupts power, temporarily removing power from a device can resolve issues related to electricity, such as voltage spikes or insufficient power delivery. Re-establishes connections, power cycling network equipment forces the device to reinitialize network connections. This can resolve issues with DHCP leasing, DNS caching, and routing tables. Refreshes software, it forces a restart of the device's software. This can resolve issues caused by software that has become unresponsive or is running incorrectly. Checks hardware, when the device powers back up, it performs a self-check. This self-check can detect and sometimes resolve hardware issues. How do you power cycle? To power cycle or reboot a modem, router, or gateway device, disconnect the power cord and wait 60 seconds before reconnecting it. Then, allow a few minutes for the device to restart fully. Once the device is fully functioning, devices should automatically reconnect to it, although if the password is not saved on the device, the user may need to manually enter it. Check cables and their connections. Faulty or loose cables can lead to various internet connectivity issues. Damaged or improperly connected cables can result in signal loss or interference, which could lead to network problems. A woman sitting and inspecting the cables connected to a modem on top of server equipment. How do you check cables and connections? Check Ethernet cables, power cables, and other possible wired connections. You might need to secure or reseat a loose cable. In other cases, you might need to replace the cable completely or seek assistance from a broadband technician. By checking cables and their connections, you can identify and fix any issues with them. Reposition the router. Proper placement of routers can significantly enhance Wi-Fi connectivity. Interference from walls, electronic devices, or other barriers can negatively affect the signal's reach. A woman standing near a mobile device, a router, and a phone. How do you reposition the router? Adjusting the location or antennae orientation can improve the router's signal strength and internet performance. You should place a router in a central location and elevate it to enhance the reach of Wi-Fi signals. You should also be sure to place routers in an area that is clear of obstructions and away from large electronics to minimize signal disruptions and interference. Try other online services. Occasionally, the issue might not be the internet connection, but rather a specific app, service, or website the user tries to access. Testing connectivity to various online services helps determine whether the issue is specific to a particular website or service or a broader network problem. Suppose a user can access some online services, but not others. In that case, the network might be functional, and the problem might be related to specific servers or services. This information helps technicians narrow the troubleshooting focus and identify the root cause more efficiently. Hands typing on a laptop computer keyboard next to a mobile phone and a tablet device. Check for service outages. External factors, such as service provider issues or regional outages, can also impact network connectivity. By checking for service outages, IT support technicians can quickly determine whether the problem is within the user's control or is a larger-scale issue. This information guides troubleshooting efforts and helps manage user expectations regarding the resolution timeline. A woman typing on a computer with a meter displaying on the screen. Update firmware. Outdated router firmware can lead to security vulnerabilities, performance degradation, and compatibility issues. Like a system reboot, a firmware update can significantly improve device functionality and security. It might also resolve network connectivity issues. Regularly updating the router's firmware ensures that it is running the latest software, complete with bug fixes, security patches, and performance improvements. This improves network stability, resolves known issues, and provides a more secure environment for networked devices. Wireless router indicator lights. The router is the central hub of a home or business network, managing all wireless connections. If there are issues with the router, it will impact the entire wireless network. The status indicator lights on a router provide valuable insights into the potential causes of network issues. Examine the following router illustration to learn about what common status indicator lights can mean. Select each marker, plus, to learn about the common router indicator lights. Power. This light indicates that the router is turned on and receiving power. A solid light typically means the power status is normal. In contrast, a blinking light can indicate that the router is booting up or in a configuration state. 1. This light indicates the status of the internet connection coming into the router from the modem. A solid light generally means a good connection, while a blinking light can indicate data transmission or connection issues. A router will usually have a WAN or an internet light, not both. Internet. This light indicates the status of the internet connection coming into the router from the modem. A solid light generally means a good connection, while a blinking light can indicate data transmission or connection issues. A router will usually have a WAN or an internet light, not both. 5 GHz frequency band. This light indicates the status of the 5 GHz wireless frequency band on the router. A solid light indicates that the 5 GHz band is active and working properly. An off or blinking light can mean the band is disabled, encountering issues, or not set up. Some Wi-Fi devices use a 5 GHz connection, some use a 2.4 GHz connection, and some can use either. 2.4 GHz frequency band. Similar to the 5 GHz frequency band light, this light indicates the status of the 2.4 GHz wireless frequency band. A steady light signifies normal operation, and a light that is blinking or off indicates it is not functioning or has connectivity problems. Some Wi-Fi devices use a 2.4 GHz connection, some use a 5 GHz connection, and some can use either. Ethernet. The Ethernet light will illuminate when a wired device is connected to an Ethernet port on the router. It might blink to show that data is being transmitted through the connection. There might be one or more Ethernet lights on the router to show the status of various Ethernet ports on the router. USB. This light indicates whether a USB device is connected and recognized by the router. Blinking can indicate data transfer or activity. Wi-Fi protected setup. WPS. This light shows whether the WPS feature is in use. Pressing a WPS button allows any device to automatically connect to the router. When the WPS button is pressed, this light blinks while it searches for devices to connect and stays lit when a secure connection is established. Routers might have slightly different indicator symbols, which are described in the specific router's manual. They will usually only have a WAN light or an internet light, but both are included here to show the commonly used image for each. Scenario: using router indicator lights to troubleshoot a wireless connectivity issue. So, how do these lights help IT support technicians troubleshoot network problems? Let's follow a scenario to learn how a technician troubleshoots a user's wireless network problem using router lights. Introduction. A woman speaking on a mobile phone and holding a laptop while standing in her living room. Moen, an IT support technician, receives a call from a user named Betty, who is experiencing network connectivity issues in her home office. Betty mentions that her devices are having trouble connecting to the internet through her Wi-Fi. Moen troubleshoots the issue by walking Betty through checking the router's indicator lights. Step 1. Inspect the power light. Moen starts by asking Betty to check the power light on the router. She says the power light is on and solid. Because a solid light indicates that the router is receiving power and is in a normal state, Moen moves on to the next light. Step 2. Analyze the internet light. Moen describes and asks Betty to look at the internet light so he can assess the router's connection to the internet. She reports that the internet light is off. Moen knows this indicates potential connectivity problems. Step 3. Examine 5 GHz and 2.4 GHz frequency band lights. Moen describes and asks Betty to check the 5 GHz and 2.4 GHz frequency band lights so he can assess the status of the wireless bands. She says the 5 GHz frequency band light is solid, but the 2.4 GHz frequency band light is blinking. This suggests to Moen that there are issues with the 2.4 GHz frequency band. Step 4. Check the Ethernet light. Next, Moen describes and asks Betty to check the Ethernet light so he can determine if any wired devices are connecting to the network. The Ethernet light is solid, which tells him there's a stable wired connection. Step 5. Check the USB light. Then, Moen describes and asks Betty to check the USB light so he can determine if any USB devices are connected. She tells Moen that the USB light is off. Moen makes a note that a USB device is not connected or not recognized by the network. Step 6. Inspect the WPS light. Finally, Moen describes and asks Betty to check the WPS light so he can determine if the WPS feature is in use. The WPS light is off, so it appears that WPS is not currently in use. Conclusion. Based on Betty's observations, Moen concludes that since the internet light is off, there's an issue with Betty's internet connection, and since the 2.4 GHz light is blinking, this signifies a potential issue with the 2.4 GHz wireless band. To continue the troubleshooting process, he advises Betty to restart the router to power cycle and establish a fresh connection to attempt to address the lack of internet connectivity. Moen also recommends that Betty check the physical connections and ensure that the router's firmware is up to date. You can observe how Moen is able to troubleshoot Betty's wireless connectivity issue using the router's indicator lights. IT support technicians who have a comprehensive understanding of the parts of a wireless router are better able to manage, troubleshoot, and secure wireless networks. This knowledge helps technicians ensure reliable network connectivity and address issues as they arise. Now that you are familiar with the lights on a wireless network router, let's explore some common issues with wireless network configurations. Wireless network configuration. If the wireless network issue is not resolved after completing basic wireless troubleshooting and inspecting the router's status indicator lights, an IT support technician can check the network configuration. Incorrect router configurations can prevent devices from connecting or accessing the Internet. To check network configurations, technicians might perform some or all of the following steps. 4 computer monitors connecting to a wireless router. Access router admin interface. IT support technicians access a router's admin interface by entering the router's IP address into a web browser. The router's IP address is typically found on the device itself. Alternatively, the IP address can be found by running an IP protocol configuration command in a command prompt. Login. Technicians use the administrator username and password to log in. Many times, if the login information has not been changed, the username will be admin, and the password might be password or 1234. Changing the username and password when installing the network is considered a best practice. Navigate to check settings. Technicians can go through the menu options to find and check network settings, wireless settings, security settings, and other relevant configurations. Review the service set identifier, SSID, and password. If users report issues connecting to the Wi-Fi network, technicians should verify that no one has inadvertently changed the SSID and that users enter the password correctly on the connecting devices. The SSID is the name of the Wi-Fi network users view when trying to connect, so IT support technicians should ensure it is correctly set and visible to users. Technicians should also check that the users are using the correct password. Review DHCP configuration. IT support technicians should confirm that the DHCP server is enabled if the network requires it and that the address pool is sufficient for all devices needing connections. The address pool is a specified range of IP addresses that the DHCP server can lease to devices on the network. If the server uses all the addresses in the pool, it can no longer assign addresses to new devices. The lease time, which determines how long a device holds an IP address before needing to renew it, should be appropriate for the network's usage patterns. Review channel and bandwidth. A channel is a specific band of radio frequencies used for transmitting and receiving data. Wi-Fi signals are divided into numerous channels within the 2.4 GHz and 5 GHz frequency bands. Channels can become overcrowded, especially in areas with many networks. IT support technicians should ensure the router is set to a channel with minimal interference. The bandwidth setting, 20 MHz, 40 MHz, 80 MHz, and so on, can also impact performance. Technicians should also ensure that any devices that are having issues can use the band that is set. Some devices, including older devices and some smart home devices, cannot connect using 5 GHz frequency bands. Review and update firmware. Outdated router firmware can lead to security vulnerabilities, performance degradation, and compatibility issues. Updating the router's firmware ensures that it is running the latest software with bug fixes, security patches, and performance improvements. Updating firmware enhances network stability, resolves known issues, and provides a more secure environment for devices. Review MAC address filtering. MAC address filtering adds an additional layer of security by allowing only devices with specific MAC addresses to connect to the network. If a legitimate device cannot connect, IT support technicians should check if its MAC address is allowed in the router's settings. By carefully reviewing and adjusting these settings, technicians can often resolve common issues that affect wireless network connectivity and performance. Testing a wireless network. Testing the wireless network ensures it is functioning optimally. Testing helps IT support technicians diagnose any issues that might be affecting network performance or connectivity. An IT support technician might test the network for device connectivity, signal coverage, or network performance issues that haven't been resolved with other troubleshooting methods. A desktop, laptop, tablet, and smartphones connecting to a server. Here are some methods that IT support technicians use to test wireless networks. Connect with different devices. IT support technicians can test connectivity by connecting to the network with different devices to verify that the issue is network-wide and not device-specific. It helps pinpoint whether the issue is related to the network configuration or the device itself. Run speed tests. IT support technicians can use online speed test tools to measure download and upload speeds. Some common speed test sites include Speed Test, opens in a new tab. By Ookla and Google Fiber Internet Speed Test, opens in a new tab. Speed tests help assess the overall performance of the network. Slow speeds can indicate bandwidth issues, network congestion, or problems with the Internet service provider. This testing method helps identify whether the network meets the expected speed requirements. Test with Wi-Fi analyzer tools. IT support technicians might use Wi-Fi analyzer tools to check for channel congestion and signal strength throughout the coverage area. These software tools are useful for diagnosing issues with Wi-Fi connectivity. They help identify sources of interference, such as other electronic devices or neighboring networks, and assist in optimizing the placement and configuration of routers for better signal quality. Analyze logs. IT support technicians can review router logs for errors, such as misconfigured network settings or unauthorized access attempts. Analyzing logs helps technicians troubleshoot network issues by identifying specific events or errors. Technicians use logs to trace the root cause of problems, monitor network health, and implement solutions to enhance network performance and security. Run diagnostic utilities. IT support technicians can run built-in router diagnostics for issues with the router's hardware or connection to the ISP. For example, ping helps determine if a device is reachable, traceroute identifies the path data takes between 2 points, and IP protocol configuration provides information about IP configurations. These diagnostic utilities assist IT support technicians in diagnosing connectivity problems and locating network slowdowns. Try it. Run a Google Fiber Internet Speed Test, opens in a new tab, to check the internet speed of your device and check out the results. Each testing method uniquely identifies and resolves different aspects of network issues, from device connectivity problems to speed and performance optimization, wireless signal analysis, log analysis, and detailed network diagnostics. Activity: testing wireless networks. Employability skills. Problem solving, attention to detail. In this activity, you will review a collection of IT support scenarios and choose the card that matches the correct wireless network testing method to use. Scenario 1. An IT support technician receives complaints about intermittent internet connectivity across various departments. They decide to check if the issue is isolated to specific types of devices or if it affects all devices connected to the network. Scenario 2. An IT support technician is investigating multiple user reports about how slow the internet is in the office today. The technician needs to determine if the issue is due to the network's performance. Scenario 3. In a large office space, employees near the conference room experience poor Wi-Fi signal quality. An IT support technician needs to identify the best location for a new router and any potential sources of interference. Scenario 4. An IT support technician notices an unexpected drop in network performance and suspects there might be unauthorized access attempts or configuration errors in the network. They need to investigate the root cause of these anomalies. Scenario 5. During a routine check, an IT support technician wants to ensure the company's router is functioning optimally and has a stable connection to the Internet Service Provider, ISP. Specifically, the technician wants to ensure there are no connectivity problems and locate any potential network slowdowns. Well done! Now, you're familiar with wireless network issues and methods that IT support technicians use to test wireless networks. Career highlight: CompTIA network and certification. Career management skills. Are you interested in troubleshooting, managing, and configuring networks? If so, you can consider getting certified. Doing so shows potential employers that you have the knowledge and skills needed to support and manage networks. Consider a certification from the Computing Technology Industry Association, CompTIA, a well-respected information technology and cybersecurity certification organization. The network and certification is for anyone who wants to troubleshoot, protect against attacks, and configure networks. The certification exam covers network fundamentals, troubleshooting, implementations, operations, and security. Activity: learn more about certification. Employability skills. Growth mindset, research. Take some time to explore the CompTIA network and certification. Access CompTIA Network Plus, opens in a new tab, and read the web page to determine your interest in pursuing this certification. Summary and looking ahead. In this lesson, you learned about common troubleshooting methods that IT support technicians use to resolve wireless network issues, including power cycling network devices, inspecting wiring, repositioning a router, trying other online services, checking for service outages, and updating firmware. You also learned about the meanings of wireless router indicator lights and explored how to check a network's configuration. You selected wireless network testing methods for various scenarios. You've completed the final lesson of this module. Next, you'll review the module's key points and explore additional resources related to network troubleshooting. Points to remember. Key concepts. 1. Network troubleshooting methodologies are systematic processes that IT support technicians use to identify, diagnose, and resolve computer network problems. A structured methodology helps ensure that issues are addressed efficiently. 2. The CompTIA troubleshooting methodology consists of 7 steps: identify the problem, establish a theory of probable cause, test the theory to determine the cause, establish a plan of action to resolve the problem, implement the solution, verify system functionality, and document findings, actions, and outcomes. 3. The Open Systems Interconnections, OSI, model divides the network communication process into 7 layers for troubleshooting: physical, data link, network, transport, session, presentation, and application. 4. Common network issues are connectivity issues or performance issues. Connectivity issues include network configuration errors, WAN problems, physical hardware malfunctions, wireless interference or weak signals, DHCP server issues, DNS server issues, firewall and security software problems, and VPN and remote access misconfigurations. Performance issues include ISP problems, network congestion, and software and server issues. 5. IT support technicians can take several steps to isolate a network issue and identify where it originates, including reviewing the network map, segmenting the network or isolating components, testing and comparing to established baseline data, and eliminating functioning segments or components. 6. Client-side issues happen on end-user devices, such as desktops, laptops, or mobile devices. 7. Server-side issues originate from the servers that provide network resources and services to those client devices. 8. Understanding the scope and scale of a network problem is a key step in effective troubleshooting. Scope refers to the range or extent of a network problem. It identifies which parts of the network the issue is affecting. Scale refers to the magnitude of the network issue in terms of its impact on business operations and processes. 9. For troubleshooting wired network issues, the steps for checking and resolving hardware issues include gathering information about the issue, conducting a visual inspection of the hardware, physically checking cables and power flow, isolating and substituting faulty hardware, conducting environmental checks to ensure devices are operating within their permissible limits, and documenting any findings or actions taken during these steps. 10. IT support technicians check wired network configurations and connectivity using various network commands. These include the following: the IP protocol configuration, ifconfig, IP, and network setup commands to check for issues such as incorrect IP addresses, subnet masks, and default gateway settings. Ping tests to check the connectivity between a computer and another networked device to determine if the host is reachable and how long it takes to exchange packets. The traceroute and tracert commands to map the journey a packet of data takes from a computer to the target destination to help pinpoint where data packets are getting delayed or lost. Network commands, including nslookup for Windows and dig for Mac OS or Linux, to perform a DNS check. 11. The steps for checking virus and malware protection include checking for updates, reviewing configuration settings, inspecting logs and quarantined areas, mitigating false positives, and testing security software. 12. When troubleshooting a wireless network, power cycling is the first action technicians typically take due to its simplicity and effectiveness. Power cycling network devices clears the device's memory, resets the device to its initial state, interrupts power, re-establishes connections, refreshes software that has become unresponsive or runs incorrectly, and initiates a self-check that detects and resolves some hardware issues. 13. Other common methods technicians use to troubleshoot wireless network issues include the following: inspecting the wiring to identify and fix any issues, repositioning the router to improve the router's signal strength and internet performance, trying other online services to determine whether the issue is specific to a particular website or if it's a broader network problem, checking for service outages, updating the firmware to ensure the hardware is running the latest software. 14. To determine the potential cause for wireless network issues, technicians can review these status indicator lights on routers, power, WAN, or Internet, 5 GHz frequency band, 2.4 GHz frequency band, Ethernet, USB, and WPS. 15. To check a wireless network configuration, technicians access the router admin interface, log in, navigate to settings, review the SSID and password, review the DHCP configuration, review channels and bandwidth, review firmware updates, and review the MAC address filtering. 16. Some methods for testing wireless networks include connecting with different devices, running speed tests, testing with Wi-Fi analyzer tools, analyzing logs, and running diagnostic utilities. Big ideas. In addition, you explored or practiced these skills. Employability skills. Analytical thinking. Isolate a network problem to identify where the issue originates. Determine the cause of a wired network issue. Check configuration and connectivity using commands, including IP protocol configuration, ping, and traceroute. Check DNS resolution. Explain the approach for checking antivirus and anti-malware software to effectively troubleshoot network connectivity issues. Attention to detail. Analyze captured network data. Change a DNS server on Windows. Identify the meaning of common router indicator lights. Test a wireless network. Problem solving. Change a DNS server on Windows. Test a wireless network. Identify the next step to troubleshoot a wireless network. Learning agility. Capture data using a troubleshooting tool. Change a DNS server on Windows. Collaboration and teaming. Work alongside a senior colleague to capture and analyze network data. Growth mindset. Explore the CompTIA network and certification. Research. Identify important information about the CompTIA network and certification. Learning objectives. Now that you've completed this module, you should be able to follow a network troubleshooting methodology. Explain the process to isolate common network issues. Use a troubleshooting tool to capture and analyze network data for a scenario. Follow the steps to check and resolve hardware issues for a wired network. Use network commands to help troubleshoot wired network issues. Change a DNS server to resolve a DNS resolution issue. Apply common methods to troubleshoot wireless networks. Select a wireless network testing method given a scenario. Explore more resources. To explore concepts covered in this module in more depth, check out these resources. 1. A Guide to Network Troubleshooting, Basic Steps, Tips, and Tools, opens in a new tab. In this article, CompTIA explains basic network troubleshooting steps and the different troubleshooting tools IT support technicians use to identify and resolve issues. 2. How to troubleshoot a router, opens in a new tab. In this article from MakeTechEasier.com, Crystal Chowder explains how to troubleshoot common issues with routers and shares frequently asked questions, FAQs. 3. What is networking, opens in a new tab. This IBM article discusses how computer networks work, the parts of computer networks, and ways to keep networks secure and working properly.